Because I'm curious, how many people or who has already trained an LLM and actually went through the entire process, like tokenization, setting up a training data set, and actually looked at the token streams? Okay, a few. As an AI guy, I naturally have to start a talk with like a quote by Karpathy. And I think he put it really interesting that like context engineering is like an art and a science at the same time, of how you can fill the context window with the right information to actually do a talk. And that's also like Toby Lutke, who's basically said the same thing. You try to put the right information and give it to the LLM so it can do whatever you want it to do. And it's for us, so I'm working at AMP, which is a coding agent by Sourcegraph. For us, it's not just like dumping all of the information in there as a human and then getting the LLM to do the coding bits. It's more of a collaboration between the agent and the human to actually do it together and figure out the right information for the task at hand. And I'm going to run through some basics. And I think, like, what is a prompt? A prompt is basically what you say to the model. Context engineering for me is more like a set of tools for both agent and humans so they can provide the necessary information. And that includes stuff that the agent can find through, for example, file reads or taking screenshots, but also enabling the human to give more stuff, which is, for example, the domain knowledge or procedures that the company is following when they're building stuff. And you can, it's a little bit small, but on the left side, you basically see context engineering, where you have the system prompt engineering. Where you have the system prompt and the user prompt, which is usually written by the developers. And then you basically expect the user to give you some input. And it's one turn, and you hope that something good comes out of it. And in context engineering, it's much more dynamic. And for me, it's like you're pulling from a gigantic space of information, which has different, like for example, docs. It has the code files, but it also, for example, can have a dev server which is running, from which you can grab screenshots or a current state, and which you can curl. And in the context window, you're basically running through it, and you have in there a lot of information: the system prompt, the user prompts, the assistant messages, the reasoning, and then the tool calls, which are actually pulling from that information space. And in the early days, GPT-2, the first LLMs were actually only trained on next token prediction. And I think like everyone knows the left side by now, that you basically have tokens and they are converted into a dense representation, and the LLM is basically churning out one at a time. And different words are tokenized differently. And to make models actually useful, we split it up into a conversational format. And I think like most of us are used to the upper part, which is like the JSON you're sending to the APIs. The lower part is actually what it's converted into. And like this fine-tuning part is much simpler than people expect. Like the conversational format is basically just special tokens which split up the text blob. And you basically have special tokens for the system message, the assistant message, the user messages. And through that, we trained the model to actually be capable of doing conversations and follow instructions. And the thing after that is actually, we wanted to get LLMs to do shit in the real world. So we basically taught them to call tools. So we introduced another token, which is a function call, which they could basically give us the name of the function and a JSON blob with the arguments. And we, on the user side, could feed it in and then basically feed back the results to the model. And modern APIs formalize around this responses format. I think this was a discussion before. Like we have a lot of fun, as Seth has, with like handling the different responses API. But all of them are around doing the same stuff. Like you have reasoning tokens, you have user messages, you have assistant messages, and you have tool users and tool results. And the model's ability to process this is basically limited by the context window. And the context window has a fixed amount of tokens. And once you hit that limit, it stops. You can't do anymore. And this is when you get that red line, or when Claude Code actually runs its auto-compaction. And what we have seen, especially like with tool calls, the conversations got a lot longer, and you had a lot of more context, which you actually had to handle. And only with Claude 3.5, with the 200,000 token window, things actually became interesting for agents, because you had enough space to actually do work in. And like the early days, I think like GPT 3.5 launched with 4K tokens, and 3.5 Turbo got to 16K, and it was really limited of what you can do with that, because it's like a couple of file reads, a couple of directory listings, and then you were basically done. And the complaints, or like the issue we still have nowadays, is the LLM is an intern which basically starts from a blank state. Like, he forgets everything when you start again. And this is why the 200K token, it's still not a lot, because the agent always starts blind, so you always have to build up the knowledge again. You have to basically look at the different files, list the different directories, find the relevant points you actually want to do the implementation in, and all of that consumes a lot of tokens. And then you have like MCPs, which often are unbounded and just feed back 50K, 100K tokens. Or the user throws in a log file with another 20 or 30K tokens, and you hit that limit really fast. And this initial orientation phase usually consumes the tokens before you write a single line of code. And power users hit that a lot. And the issue isn't like you can restart or like try to divide up your chunks, but usually we are too lazy to build up that context again, because it takes a lot of time, it costs a lot of money, because we have to churn through a lot of tokens again. And this is where like context engineering really started. We built a tool that allowed us to reduce the amount of tokens in the same chat. And initially, that always looked like we are doing summarization, truncation, like we throw away the early tool calls, assistant messages, or we used RAG with really tight filters. And this solved the capacity issue we had. And a lot of people always like tell us on Twitter, like, okay, yeah, 1 million context window actually solves this. But in my opinion, not really. Like, long context gets really expensive. Once you hit the 200K limit, like in Anthropic, the price is double. So it gets really expensive when you go over that. And this happens because you can't batch as efficiently anymore at that context size. And at the same time, the quality degrades. Like, a lot of people probably have read like the needle in the haystack, where especially like Gemini is very good at. But usually that doesn't tell you much about how well an agent can actually utilize the context. So usually they just put like one password, like one string in there, and ask them all, hey, what is the secret string which is in that blob of text? And they can extract it. And they basically show, hey, it works well up to 1 million context size. But what we want the agent to do is actual work, spend reasoning token and actually do stuff with the context and continue working. And this is what doesn't work at that context size. And what we usually see is like at around 300,000 tokens, the quality degrades really quickly. And the promised solution was compact. And compact, for the people who doesn't know it, it basically generates a summary with a potential user input and appends it to the conversation thread. And this is basically a marker. And everything before that, besides the system prompt and the tool definitions, is ignored. So it reduces the amount of context. But at the same time, for me, it's a little bit of a half measure, because it only serves for quantity and not really for quality. Because you don't really know like what context is going to be ignored, and is actually the content ignored that I can discard, or is the context ignored which I actually told the model, hey, I want to use this language, you have to optimize for this and this, like I'm going more for readability over performance, and it's very likely that it's going to forget some parts which I have built up, which are still really relevant. And sub-agents, this is a little bit of a hot take for me, are the same. Because sub-agents basically are a way for the model to prompt another agent to do work for it. So they reduce the quantity of work that the model has to do in one context window. And they also focus solely on quantity, because it isn't really guaranteed that, hey, they are going to give relevant context, relevant instructions, so the sub-agents can do really good work. And this is likely copy from a friend of mine, Dex Horthy. What do we actually want in a context window? And for one, it's like correctness. Like we want correct information and that isn't disagreeing especially. And this is what we see a lot with MCP servers that grab over documentation. Usually documentation has, or like each library has multiple ways of doing it. And when you are tackling a problem, you're very likely to get both ways. And then it's up to the agent to basically figure out which one you use. And in most cases, it's gonna pick the wrong one. The second one is completeness, basically all the information you need to do the task, but not more. Then size, which is very related, like remove the noise, keep the signal, and lastly, trajectory. You want to have a good loop, good decision making, where the model basically keeps a track and just can keep going. And if all of this is given, you probably can keep a thread going for like very long, like beyond the 300K limit. But it's very unlikely that actually all of those is given, because the model is gonna get some files which are irrelevant in its discovery process. You're gonna give some bad instructions which leave stuff up to interpretation by the model, and it's gonna make some wrong choices and then you correct it. So all of them likely not given, so we have to actually do something else. And for me, LLMs are poor functions. So it's token in, token out. So when we have garbage input, we're gonna have garbage output. And I'm gonna skip over that or like speed run through it. What not to do is a lot of like do multiple tasks in the same thread, which are fully unrelated. So basically you're in the same context window and you do two fully unrelated tasks because it's just gonna be confused by the earlier context window. You provide too much context or way too little. Or I think like what's coming more and more is like splitting work up into phases, like doing planning, coding, and then reviewing in different conversations. And this is also like in the do. I really like to hand curate my context. So instead of having context 7 as an MCP, I'm gonna go on the documentation myself and look up the relevant pages and copy the URLs and feed it in. I do focus tasks with a limited set of files. I isolate the features. I like to tidy and refactor first. So it's actually easier to integrate and I can isolate the feature I'm building and a bunch of other stuffs. One more, which like Mitchell Hashimoto, for example, is doing a lot. He forks and restarts threads a lot. So when he sees like a thread is going off the rail, he just stops it and restarts. Or when he wants to do like multiple small edits, he forks the thread 3 times and does them in parallel. And what we see a lot with our power users is they split depth into stages, they restart a lot, fork into new threads, and hand off tasks. And they do it a lot with markdown files. So they write a plan to a file, take the plan in the next thread, and just continue working based on that, and then execute it. And at AMP, these are like the tools I want to build. Like to keep the context clean and clean it up for the user, and also figure out tools that allow the user to easily create new threads and split work into phases, and also build up knowledge that can be reused. And for example, this is like the workflow we use, like the plan mode, which is in early access if you can find the flag. It basically is a special mode where the model only has access to a certain amount of tools and basically only iterates on a plan of what I want to execute. And then once you're finished, you basically click on execute, you spin up a new thread, and there the execution starts. And usually all of the relevant context should already be in the plan and the relevant files are mentioned. So you can skip the initial discovery phase and go right into implementation. And these structured phases usually allow you also like to do quick reviews. Like you can look at the plan and actually fact check it a little bit, whether it's valid, whether you as a developer actually think it's touching the right files, it's touching the right modules, and it's doing the right amount of work. And then it's suggesting like a 16-step plans with like 500 lines of code change. You already know like it's probably gonna do something bad. And this is very late. Like I love the notion of artifacts, and this is a little bit of an optimistic take I have. I think always like you can create dense representations of a conversation which contain a lot of the relevant information, but use up a lot less context window. And these could be instructions, this could be procedures to tell the model how to do something. It could also be the domain knowledge that answers why something is relevant. And this is stuff I'm trying to build right now. Like, how can we actually extract it for companies over multiple threads the same user has or a lot of users have? Or how can our engineering leaders or engineering managers actually give you some guidance on like how to write threads? And this is a lot of stuff like context packages are, for example, one thing like where I try to figure out, okay, what are the right set of instructions, the trade-offs, and also set of files which represent a feature, like a map basically of the code base. Knowledge artifacts is basically what usually the staff engineers in a company write up. Like they sit down and figure out, okay, how do we actually write tests? Set of patches is something new. Like I'm thinking like I want multiple implementations of the same feature and actually look at, hey, which is the one I prefer? And this we represent as a set of patches. So I can basically spin up the different ones, look at them, see how they perform, and then pick the one I like, or use an agent to pick the best one. And there's also one agent can't do everything well. And we use a lot of different providers for different tasks. Like planning mode is using GPT-5 because it likes to do a lot of reading before it actually starts to do something, which is annoying for a lot of development work because it just takes a shit ton of time. But for planning, you actually want that if you implement a bigger feature, that it explores the code base. We have a new one, which is the Kraken model, which is basically a really fast one, which is for like larger refactors. If you don't like the refactoring tools yet and you just want to be lazy and tell the model to do it, you basically can get like every place where something like a wrong function when you're migrating to a new version is placed and tell it, okay, migrate this, and it will do it. The code-based search agent for exploration are also a review tool for reviews. And each agent basically has the right tool set for the task and only these tools, and produces an artifact which can then be handed to another agent and reused. Handoff is a new feature we launched, which, for example, is by answer to compact. And it's basically the user and the agent working together. The user is telling the model, hey, what do I want to do next? What is the next task? And the model is only from the current thread extracting all the relevant files and the relevant instruction already given and putting them into a new thread for you. And then you can edit it, review it, and start the new thread. Which doesn't get you into the compaction loop where you're never sure, hey, is the right information actually in there? Threads as first-class citizens and strategic forgetting is like threads as first-class citizens, basically grabbing them and like doing a search on top of them. Strategic forgetting, does anyone know Factory AI and Droid? Yeah. Yeah, I love the guys, and they have strategic forgetting as one of the main things. And I have a little bit of a hot take as well. You basically decay old information, which is interesting as a concept, but I think that it's a bad take because in models you have prefix caching. So basically, up to a certain point, the longest possible prefix is cached, and it costs you way less money, and it's also way faster. And when you forget the really old information, everything after that is invalidated. And what we are wanting to do is like basically early aggressive pruning. So when you recognize the model is doing bad edits, it's doing failed tool calls, you prune them aggressively as they happen so you can keep the cache intact. And as a last one, it's like no one has figured it out yet. Also, not us, not me. And these are all just ideas we are throwing out there, and everyone is experimenting in the space. And I think like if you're doing context engineering or trying to figure out agents, I think like it's just like throwing shit at the wall and seeing what sticks and what actually works. Because it's not really a science, it's more like an art and a science at the same time. Yeah, that's me. If you want to find me, I'm like on every social media. I'm working at AMP. I also have a podcast. And I think I can claim the term context engineering got coined on my podcast. I have the earliest reference and I fact checked that.